Are we starting to review packet today? We're gonna finish up the 8.10 review, and then second half of class will start the. You guys can turn to page 27. I think we did the evens, so we're gonna finish up with the odds. And then we'll start the new review packet. Page 27. This is the evens, right? We did the odds. So, yeah, I'm just gonna have you guys work the problems, and I will show the answers and go through anything that stands out to me. But really, just thanks for you guys to get some additional practice. If you're finished with this, go ahead and start the new packet. So. Look at that. Any coefficient, go ahead and bring those up first. And then, in this case, you can use quotient property. Get it down to one log statement. And we can continue cleaning up because there's some factoring after this that allows us to, first off, we're going to expand that x plus one squared, the x plus on its own, x plus one squared, x plus one cancels out. We can get our expression to reduce down to log of x plus one over x minus one. Number 13. So the numbering got messed up here. So go down to 13 and 15. So we're trying to solve for a variable with the x on it. Look to see is there an easy way to get the bases to match with the same numbers? If there is, then that's a little bit easier and faster than having to go through logs. We usually go through logs if we're kind of stuck and not able to resolve match the bases, and then use logs to bring the exponent down. But I think number 13 allows us to match the bases, right? 81 get rid of things like there's a 9. Oh, right. So I brought everything down in terms of 3, but could have also done this in terms of left the left side alone and 81 9 squared. The way you do 3.
I think it's up to you. Yeah, I think in this case, maybe 9's a little bit easier because you only have to change one side, but, you should get the same thing either way.
For those instances where you can have multiple, bases and still work, usually that's not the case. Usually there's only, there's one, if at all. There's one of the rare cases where you say 3 or 8 times. Those problems at most only have one.
Any questions with 13?
Okay, 15. I want to solve for x, like the stuff for exponents, so let's see how much we can get cleaned up. So we combine some like terms, get 13 and 5 together, get that 4 to
Divide over. So 13 and 5 add to 18, divide both sides by 4.
18 over 4 is 4.5.
So it's not a clean whole number, but that's okay. We can still take the natural log of both sides to allow the 2x to come down, and then we can just continue algebraically solve for x.
So natural log of b is just 1.
Okay, 17.
Hopefully we see that and recognize the need for factoring. Oh, 16, yeah.
We went through the events yesterday, but I'll insert the answer.
Attach to your second packet. Oh, okay, so first one? Yeah. Okay, so 17, we do see the need for factoring, so
Let y represent e to the x.
y squared minus 2y minus 10 is a lot easier to factor. More familiar. 1 by 2 negative 10, add to 2 negative 3.
Once you get factoring to appear, then bring the e to the x back and look for x after x.
So, once we bring e to the x back, then we basically, made our way down to 2 simpler problems. So e to the x equals 5, e to the x equals negative 2. We're stuck in a situation where we have to involve, natural log to bring the x down. So take the natural log to both sides. X equals natural log of 5 on the left side. On the right side, natural log of negative 2 is undefined, right? Natural log or log, we can't have log of a negative number. so there's no solution on that side. Take a look at 19. Typically, we would like to get the bases to match. So we can cancel that out, but in this case, base 4 and base 11, we're not gonna be able to find the common base easily, so, we're gonna involve log, right? So take log of both sides. Bring those exponents down. Notice that the exponent has multiple terms, so you wanna protect that. Once you bring the exponents down, make sure you protect it with a set of parentheses as a reminder that something has to distribute through both those terms, down the road.
Why the x squared function should be like x minus. Oh, never mind. I think it's wrong.
Only for number 18.
Yeah.
So this is one of those strange cases where,
The factoring has a higher degree than what you're normally used to. Typically, it's just x squared and x. In this case, it's x to the fourth and x squared, so, your factoring is not gonna be x and x, and x.
so for 19, I left my answer in log form, but you could have plugged all this in the calculator, get a decimal number as well, that's fine. That's my answer, simplified. But, still, the big idea here is we're just trying to get x by itself. Whatever way we can get x by itself, so I distribute everything through, so I can have an easier time moving things around, and then I'm just going to rearrange, get the x's on the same side, get the constants on the other side, factor out the x and divide over.
Page 28, 21, and 23. Now, the difference with page 28 is these are log equations. So log equations means that in the end, when you solve for x, you gotta make sure you insert your x solution back into your original equation and see if there's any conflict. They're gonna cause any expression to produce a negative value number. I can't have log of a negative value. So I may end up with extraneous solution that I have to remove from my answer choice. But we only do this if you see a log or natural log equation to begin with. If it's an exponential equation like these, this usually doesn't matter, right? Unless you get to a point where you solve for x and something else is telling you that it's otherwise, you solve for x, that x usually goes. It does that. There's no need to worry about extraneous solutions with exponential function. 21. The strategy here is if your x is stuck inside a log or natural log, find a way to get it into exponential form. Usually that will release the variable away from that log or natural log, and then you can have more options available to solve. So here, let's combine some like terms though. We can get the 5 and 5 to go away. You may want to rewrite that natural log as log base e to see the base more clearly. get it exponential. E to the 0 equals 3x. Anything to the 0 power is 1. X is 1/3. That's 1/3 into, I'm going to highlight what you're going to test against. You're testing against the parentheses there. 1/3 in for x, no issues, right? 3 times 1/3 is positive 1. Natural log of 1 is safe. #23, we've seen natural log on both sides, so we would like to cancel the natural logs out, but there's something that we need to take care of first. 2, right? That 2 is a little bit out of place. You want natural log equal to a natural log, but where can we push that 2? Exponent, yeah. So once that 2 comes up as an exponent, we can have a nice one-to-one relationship here, natural log, get the natural log to go away, and then you can just set 4x squared equals x plus 4 squared. It end up still being a factoring problem though. Boil everything out, combine like terms, bring everything over to one side.
Take over the, like, log thing that, like,
Yeah, you can do that, that's right. I can show the work through the factoring if you want to see it. So multiplies to be negative 48, which is a times c, and adds it to be -8. The two numbers are -12 and 4. -12 times 4 is -48. -12 plus 4 is -8. Look at these fractions. That 3 is coming from that leading coefficient. Reduce. And then from there, continue. You can also do this using grouping method. So grouping method, you still go through a times c, -48, adds it to be multiplies with -48, adds it to be -8. You still have -12 and 4, but now you can break that -8x into -12x and 4x. And then you can GCF the rest of the way. Factor. Put the parentheses together, put the non-parentheses together. Sorry, x squared, just x. Okay, so we get positive 4 and -4/3. Test them both against your original equation, and they both work.
-4/3. Usually negative is an issue, but it's not going to cause an issue with that x squared. Nor will it give me an issue with the x plus 4. Okay, 25 with graphing. And 27 with graphing. And so the 3 main properties to keep in mind: log of 0 is where your vertical asymptote is. Log of 1 is 0, and log base b of b is equal to 1. So when you take advantage of those properties, we can find some easy order pairs to graph. Now, this is an additional property. You don't have to use this. This is basically saying that if I can force a 1 over b inside my parentheses, then log base b of 1 over b is equal to -1. So that's just another option for order pair, but really all you need is the vertical asymptote. Log 1 equals 0, and log base b of b equals 1. Okay, we did 26 already, so go to 27, and then we'll move on to the review worksheet 2. Packet 2. So worksheet 2, let's see if we can go through the odds today. And then we'll do the evens tomorrow. Okay, worksheet 2.
It's a test format.
It'll be front and back. These worksheets are a lot longer than your actual test, but you'll have, 1 or 2 from each category.
Okay.
Yeah. Okay, so let's work through the odds on worksheet 2. And I'll show the answers. Again, you guys have to key attach to your packet, but I'll pace us through these problems as well. Oh, sorry, yeah. Yeah, don't worry about the x-intercept. You can just do domain and range. Okay, there we go with 27. The bases don't really have much opportunity to match, so this involves logs to bring that exponent down. Number 3, I do want to solve for x, but let's see if we can do some cleanup first. Let's get that 7 away from that left side. And then we can take the natural log of both sides. Allow that x minus 3 to come down. Again, we're just doing the odds today, and then we can finish up with the evens tomorrow. And there's no need to test our solutions. We only have to test our solutions if we have a log or natural log equation as our starting point. Exponential equations are fine. Number 5. That left side is as cleaned up as we can get. We can jump directly into taking the natural log of both sides, bring that 3 minus 2x down. Okay, number 7, combine like terms, see how far I can get. So 4 to the x minus 5 equals 3. I add 5 to both sides. 4 to the x equals 8. Okay, there are 2 options here. You guys can choose either one, but can you name the 2 options that we have available to us here? Yeah, get the bases to match or take the what? Take the exponent down by taking the log, log of both sides, right? You can do natural log, yeah, but I did log base 10. But here, yeah, that works perfectly fine. But if you want to match the bases, you can as well. Either way, you'll get the same answer. But Okay, try number 9. Number 9 feels easy because the bases match. I can just drop the bases out and solve for x. Okay, let's just do the odds on page 2 and then we can take up tomorrow. Okay, so page 2, odds. So now we're solving log equations. Clean up as much as you can, but eventually you're gonna have to get it into exponential form to release that variable away from that log expression. Make sure you check your answer choice. Your candidate needs to you have to be able to insert into the expression inside the log. Make sure it doesn't produce a negative value. If it does, we have to consider that as no solution. But 30 is fine. 30 in for x plus 2. No issues there. Okay, 13. We do want to solve for x. X is stuck inside the log expression. We do want to convert to exponential form, but there's a few things we should do first. Let's get the 16, the 4, and the 3 to somehow come together as one term before we convert into exponential form. So let's combine some like terms first. The hidden base is base 10. Okay, a few more. 15. We'll do 15, 17, and 19. Divide that 4 over first. Get that base to show up for you and then exponential form. double check your solution with your parentheses, right? You want to make sure that there's no conflict. 0.774 is not going to create a conflict, so we're safe. Okay, two more, 17 and 19. Okay, so 17, we definitely, it's nice seeing natural log on both sides of the equation, but before we can drop the natural logs out, we have to find a way to get that right side to clean up a little better here. So quotient property, right? Quotient property on the right side, get that right side down to one natural log term, and then once you have a one-to-one relationship, you can then take the natural log away from both sides of the equation. That's fine. No, that's good. Yeah, that's good. Good music. So with 17, when you solve for x, I got -3 and -2, but they're both are going to present issues with at least one of those terms. So in this case, we have no solution with 17. Thank you. Okay, last one, number 19. Log base 5, log base 5. Again, there's no need to do any additional cleanup. We're ready to move on to our next step, setting our two parentheses equal to each other. Solve for R. Make sure R does not, that -3 does not cause any issue. It does not cause any issue with either of the highlighted expressions, so we're good. -3 does stand as our solution. Okay, any questions? Okay, so tomorrow we will finish the rest of worksheet 2, and we'll also circle back and do the evens. All right, get your phones. One more day for review, Friday HO test.
Levels of evidence.
Yeah.
You do, so, you know, the ice, like, what's the beginning?
Sounds good. Now do that.
So if you have a vertical shift transformation on your graph, does that only affect the y value?
That's right, only affects the y value. Yeah, that's right.
And also, is there any calculators about?
Yeah, you get these about the. Yeah.
Okay, we can go cancel, can I stay Friday like?
That's good. All right.
I thought it was like the area. It was well, maybe I was like, a machine. You're not. Yeah, I'm also. The doctor said I know. We're a little shot my.
Don't think it's from a lot of. It's been like that. Yeah, over here,
Yeah, then just use it.
it's all good, the weather is old.